Currently staying in Chennai. Past 3 years and working in the system admin in Linux admin. That's all.
Okay, thank you. And Kiran Mai?
Yeah, good evening, everyone. This is Kiranmai Chindala. I have 1.5 years experience in TCS. So I'm working on Unix domain, Unix and SQL.
Okay, thank you. And Nagbhushan?
Hi, good evening, everyone. I have overall 3 years of experience in various companies. Currently, I am working in testing domain.
Okay, thank you. And Sai Venkatesh?
Yes, sir.
Yeah, can you brief about yourself?
Yeah, I'm Sarang Desh. I'm from Mongol. I have 1 year experience in Broadridge. Currently, I'm working on L2 support. I'm supporting both technologies like Java and AWS.
Okay, thank you. And Sai Kumar?
Yeah, hi Ganesh. Good evening. Good evening. Yeah, my name is Sai Kumar Pattapalam. I have more than 1.10 months of visa experience.
You need to be a bit louder, Sai.
Hello, am I audible now?
A bit louder, please.
Hello.
Yes, you're audible now.
Yeah, go ahead. Yes, Sai Kumar, you can go ahead. And Siva Prakash? Are you there, Shiva Prakash? And Ujjwal?
Hi everyone, good evening. I am Ujjwal. I am from Delhi. I have 1.5 year experience in the desktop support, and my current company is the Microland Limited.
Thank you. Thank you, everyone. Thanks for your time. Yeah, Ram, you can go ahead.
Hello, and welcome to this session on Introduction to DevOps. If I may tell this, you can also call it Roadmap to DevOps. Yeah, many of you are into support. Yeah, I have understood that, spoken to, listen to everyone's intro. So let me also tell me about myself. My name is Ram. I have around 7 years of experience, 7+ if you ask me. I'm also training people from past 5 years. So I worked in different MNCs in different roles until now. So I started my life as a manual tester, then I got migrated into Linux, then into AWS, and then now into DevOps. So it's a sequential upgrade, if you ask me, to my career. So also I am AWS Certified Solution Architect Associate as well as Azure Administrator. So starting my life as Linux administrator, I came from the ops side into the DevOps. So there are so many people who you might have listened about, who are developers who came into DevOps. You can see some testers coming into DevOps. You can see some support people or the operation people's coming into DevOps. Most of the time we'll be listening about people from ops getting into DevOps, correct? Yes or no? Yes? No? Hello?
Yes, sir.
Yes?
Yes, sir.
Am I
Yes.
audible?
Yes, you are audible.
Yes, you are audible.
Okay.
Yes, sir.
I want the communication to be two-way. All right. All my training sessions go like that because I always go by listening, right? I can't see you. I can't see your faces. So you should be answering me in yes or no because I have to know whether you're listening or not. Okay. Great. So first of all, when we are talking about the demo about DevOps or when we are calling or talking about the roadmap to DevOps, there's so many things that will come into picture, right? when somebody comes to you and talks to you about DevOps, what will you say? So there are so many tools. This is what you will be telling, right? So many tools, so much of technology to learn, correct or not? Yes.
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 And I don't know where to start. Don't know where to start. These are the questions that these are the things which these are the statements we make, correct? Yes or no?
Yes,
Yes.
sir.
Yes.
So coming to the DevOps is not a tool. Okay? DevOps is not a tool. DevOps is a process. DevOps is a process. When we are talking about DevOps, there are two terms in this, Dev plus Ops. Dev is development, and Ops is operations. Correct, right, Kiran, you're spot on. So development plus operations. So earlier, if you go to the SDLCs, the software development life cycles, they used to be waterfall models, agile models take over, right? Agile technologies take over, right? And then after the agile technologies came into picture, we also went into the DevOps nuances, correct or not? The DevOps nuances are what we are following right now. Each and every company follows a certain DevOps nuance to make their release process efficient, correct or not? So we all are the consumers of the softwares big tech companies make, correct or not? We are using Zoom right now. We are using Microsoft Windows right now, correct? We are using an operating system now. We are using a tool now. These are all the softwares, correct? Right or not? We are using Android phones. We are using iOS, correct? Even we are using Google TVs, right? We are being an end user or the user of so many softwares. So when I talk to you about Android, what comes into picture? What is the version? What is the current version you are using? This is the question you will be asking, correct or not? Whenever you take a phone, for example, OnePlus, okay, which Android version is it? That's the first question you will be asking, correct or not? Yes, no? Yes or no? Hello?
Yes, sir.
Yes, sir.
So somebody should have to take the lead to say yes or no, because I have to continue with it, because I have to understand you're there, right? So you'll be asking, what is the current version? So what is the current version of Android? Anyone using Android phone or iOS? What is the current version of iOS or Android? iOS is 17. I'm using an iOS phone, so I'm using an Apple phone, so it is iOS 17. So when it is iOS 17, there are 16 versions before this, correct or not? Hello? And with each and every version, there are new features, correct or not? There are new features. Then there are new upgrades, new fixes, correct or not? New bug fixes, etc. For example, first when iOS 17 came, there was heating issue. Somebody is sleeping. So there were sleeping issues. Sorry, there are heating issues, just like we have sleeping issues. So now they fixed it. So there is something that is running in the background that is making these fixes happening continuously. There is continuous integration and continuous delivery. This is the heart of DevOps, continuous integration and continuous delivery. Why is this very, very important? Why is this very, very, very important? So when we are talking about continuous integration and continuous delivery, it's a broad term. We'll be talking about sending version by version outside, sending version by version outside. When you see the DevOps flow, how will it look? First of all, it's an infinite loop. What is infinity? Anyone can you tell me what is infinity? Infinity is something which is never ending, correct or not?
Yes.
It is continuous, it is never ending. It goes on and on and on and on till you drop it, right? So first they will be planning. What they will be planning. For example, I need to make an application. For example, I need to make an application. What application do I want to make is the first question that will come into picture. For example, I want to make an e-commerce website, just like Flipkart or Amazon or something else. Then there are categories of what you will be selling. Then there will be payment gateway, then there will be checkout. These are the basic things that you will be providing. Then there are so many other features that are there. For example, you want to buy what? You want to buy electronic appliance, you want to buy home furnitures, you want to buy a simple pen, you want to buy a pencil, eraser, everything. So these are all listed on Amazon, correct or not? For example, if you go to Amazon.com, you'll be seeing so many things. So if you go into Amazon.com, you'll be seeing so many things, so many options are there. If I want to buy something, yeah, I can go for the deals, or I can search for something, or I can go to the drop down and select. I want to go into the sports. I want to buy something, sports equipment. I want to buy. I'll just hit an enter and then I'll go here. I'll see different things that are there here. So like this, there is the unlimited flow of options that are there on this website. So these are all developed by who? Developers will develop it. How will they develop it? First of all, there is a plan. So what to do with the current software? What is the main use of the application you are developing? That should be there. And then there are list of things that need to be coming in a certain way so that the end user can use it. Then coding happens. After coding happens, some build tool will be there. For example, there are so many developers who will be writing code. No one developer codes the entire application, because you just saw Amazon.in. It's huge, right? It has so many modules. So all the modules are coded by the developers. Okay, the developers are coding it. Where will they save it? Where will they save it? They will save it in repositories like Git. They will save it in repositories like GitHub. GitHub will contain so many repositories. There are public repositories, private repositories. And in some private repository, they will be putting their they will be putting their code. This is also used for the source code management, if you are asking me. So Git is there. Okay. So once the code is all put into the Git, you need a build tool to make a ZAR file or an EAR file or a zip file. If it is a Java application, somebody is working with Java in this class. So you will be making a ZAR file. Once you make a ZAR file, what will you do it? Where will you deploy it? You will be testing the code first, then you will be building it, then testing it, and the release you will deploy it. You will deploy it where? You will deploy it on a server. You will deploy it on a particular server so that all the people will come to that particular server and utilize your application. That's the simplest thing you can say. So if you are seeing at the 100-foot thing, it is just coding, building, and deploying. Okay, fine. Coding, building, deploying. Okay. We are doing planning, coding, building, testing, and there is something called release here. What is happening in the release? For example, I have done the deployment. There is no release, let us say. Deployment, then operate, then monitor, then plan. So what happens here is there is lack of transparency. And there are certain roadblocks that are also there. For example, in the DevOps environment, every team will be collaborating with the other teams and they will be talking to each other and they will be planning the sustained release of a particular software or the versions of the softwares continuously. Usually what happens is usually what happens is there is an idea, there will be implementation, then there will be testing, then there will be building, then there will be deploying, then there will be observing, then they come with the new ideas. This is the loop they go in all the time. So in the DevOps environment, what is happening? All the teams are collaborating to each other and they are not doing anything manually. For example, this entire process which is there, if you are doing manually, what happens? Developers should have to manually do everything. Then testers have to manually test everything. Then the infra people must be configuring the infrastructure manually. Then the configuration management of the server should be happening manually. If everything is happening manually, there is a lot of documentation. Then there is lack of transparency about who did what. For example, I gave someone to do install an Apache server. That particular guy does the Apache server installation. Now there is documentation from that guy. I need to ask the documentation, read it, then understand what is happening and work on it. These are certain roadblocks that are making things, making things very hard for the release to happen sustainably. So here, what are we doing? We are making the teams talk to each other and we are making the collaboration and automation possible. Collaboration and automation possible. What is happening? What is collaboration and what is automation? Let us see. So for example, the developers are using GitHub to keep their code. Okay, to keep their code. So they are keeping their code there. So you should also have an idea about, as an ops person or a DevOps person, you should also have an idea about the GitHub and the Git tools, correct? GitHub as well as the Git, to understand what is happening inside that particular repository. For example, somebody is building it. So what is happening in the building? So first, what happens? First, code happens. After the code, testing happens. After the testing, what happens? There is build and package. Once the build and package is done, they will be sent to the ops. Ops people always need stability. Ops people always need something called stability. But the developers are pushed to send more and more features. So they want faster upgrades or updates. And the ops people need stability. And the security people will be seeing that, is this application creating any disturbance to the security that is underlying? So what happens is, for the stability, we will be going for DevOps, and for the security, we will be going for DevSecOps. We won't be dealing with the DevSecOps because security is another underlying thing that is there. So when it comes to the DevOps, for example, anything that goes should go without any frictions and roadblocks. For example, miscommunication is there, conflict of interest is there, otherwise security is there, application testing is there. These are the several things which will be hindering the stability of the flow of software that is happening. For example, let us take the planning and collaborating. When we are planning and collaborating, there are so many tools that will come into picture. For example, including the source code management. There is source code management, SCM. Then there is CI/CD, continuous integration and continuous delivery. Then there is package management. Then there is containers and orchestration. Then there is infrastructure as code, which will be working on cloud. Then there will be monitoring. And all these things will work hand in hand so that there is no miscommunication. And here we have to know the boundaries also. There are boundaries for DevOps engineers. You can't really step into the developer's field and say something to the developer, or the developer should not enter into the DevOps field and say something to the DevOps guy. So what happens is you need to have a certain idea about certain things. For example, let us take Linux. For example, where is your application running? Your application will be running into the servers. For example, once the build is done, let us say, once the build is done, keep the CI/CD aside for some time. Once the build is done, we will be putting it on a server and running it. Okay. So this server will be containing an operating system, correct or not? This operating system can be Linux operating system or Windows operating system or some other operating system, any operating system. 90% of the companies will be using Linux operating system because it is stable and reliable. So somebody is working with the Unix operating system also, right? So Linux operating system. In the Linux operating system, you need to know the in and out of Linux. Some people will be saying just learn the basics of the Linux and you're good, but you have to harness the full power of Linux so that you can learn DevOps well. So you need to have the basic Linux administration in your hand. And then once the Linux administration is there, you can do the configuration management also, because the Linux administration comes with Ansible. Because Ansible is one tool you will be using. Ansible is one thing you will be using for the configuration management. Configuration management. And then where are these servers located? These servers are located in cloud. On cloud otherwise. What cloud? Preferably, there are so many cloud service providers like AWS is there, Azure is there. Many of them are there. For them, you can't manually go and tweak the cloud each and every day, right? For that, you have infrastructure as code. Infrastructure as code. Infrastructure as a code, we have a tool called Terraform. Once you learn the in and outs of AWS, you can easily do Terraform. Once you know the Linux administration in and out, you can be doing Ansible really well. So these are interconnected to each other. Even the basics of the Linux will go into the cloud. In the cloud also, for example, there is user administration. That user administration will become IAM here, which is identity access management here. And there is storage. Then there is DNS here. The DNS becomes Route 53, Route 52 in here in AWS. So there are so many services that are there which are interconnected to each other. So learning Linux will harness the full power of the DevOps engineer. So now Terraform we have talked about. Then virtualization, earlier we used to use the virtual machines in the infrastructure, virtualizations. There used to be VMware. After VMware, there came cloud. After cloud, we are now into the virtualization with containers. We are using something like Docker. There are some Docker commands we will be running and we will be creating the Docker images. These images will be deployed onto the servers. These images will be deployed onto the servers. And for the container orchestration, we have something like Docker Compose or Kubernetes. For example, if your application is small or medium, you can use the Docker Compose for container orchestration, right? Otherwise, if you have many microservices that are there, you will be using something called Kubernetes. So and continuously whatever is happening in your environment should be monitored. For example, if you are doing any configuration management changes, if you are making any orchestration changes, if you are creating any infrastructures using Terraform or something like that, everything should be monitored. And for that, we will be using tools like Nagios or Prometheus, right? And then there are so many things that are there. For example, for the log management, we will be using something called Splunk. Otherwise, we'll be using something called ELK stack. There are so many tools that will come into picture. But if we are discussing about each and every tool randomly, you may not get it properly. So what happens here is understanding something that happens. So first planning, then coding, then building, understood? Then testing, then releasing, then deploying, then operating, then monitoring, then again planning. So here, from the code to test and test to code, there will be something called continuous integration. Here, if you have any bugs, if you have any problems, if you have anything that need to be done again and again and again, here the continuous integration will be happening. Once coded, then build, then test, code, build, test, code, build, test. This will be continuous integration part. From the same test, we'll put the test in the middle so that you will understand it better. From the same test to test, release, deploy, there will be continuous delivery. So the coding here will be developing the new features, and the deploying here will be releasing the new features. For example, 1.0.0 got released. Some bugs are there, some minor fixes are there. We have released 1.0.1. Then there will be 1.0.2. If there are any medium level bug fixes, then there is 1.1.0. Then like that, it will go on, and it will become 2.0.0. And this particular versioning, it is different with every other company. For example, for the minor, somebody will be using 3 dots, somebody will be using 3 figures, somebody will be using 4 figures. It really depends upon the company and the nuances they follow. So this is how the continuous delivery and continuous deployment happening. So what happens here in the development? So first, in the coding, in the planning part, your business analyst will go and get the requirements. Here the requirement gathering will be done, and then there will be brainstorming. In the coding, they will be using some stack to make things work in the programming. For example, they will be using Java stack. Otherwise, they will be using .NET stack or some other frameworks, Ruby, any application development environment that is there. Then once it is happening, once the programming is done, all the programs will be saved into something called GitHub. GitHub is a repository where we will be putting all the code. Okay, fine. Once the code is put somewhere, then they will be running some unit testing for the code quality testing. For example, they will be using SonarQube or JFrog or something else to get the code quality right. Once the code quality is right, they will be using a build tool like Maven or Gradle or NPM. There are so many tools that will be coming into picture. These tools we will be using for building. For example, a jar file is built, EAR file is built, otherwise a zip file is built, anything. Then there will be building a Docker image. By using what they will be building a Docker image, they will be using Docker. Once the Docker image is set, it will be sent to the Artifactory repo. Okay, here there will be, I told you that in the Maven Gradle, here we'll be making a jar file or an EAR file. This particular thing is called artifact. This thing is called artifact, and these are also stored in something called artifactories. After building a Docker image, they will again push that particular artifact into the Artifactory repo also. That is why you need Artifactory also. You need a tool which deals with the Artifactory. So that is also there. Then once it is pushed, it will be pushed on to the operations side, ops side. In the ops side, there will be servers. Here what happens, once this is happening, the versioning, the continuous integration and continuous delivery, that will be happening over Jenkins. Nice. So this thing becomes continuous right now by using the Jenkins. Once the code is done, the code quality is tested, Once the build is done, build the Docker image, use the Jenkins, the CI/CD, this will be rotating here. Then the files go on to the servers. Here, when it comes to the servers, where are these servers sitting? These servers are either sitting in your data center or on cloud. When we are talking about data center, we will be talking about on-prem. We call it on-premises, on-prem. So on-prem or on cloud. So most of the companies are using hybrid cloud environment. What is hybrid cloud environment? In the hybrid cloud environment, we will be having our own data centers as well as we will be using the cloud infrastructure, and it is planned accordingly. So now here AWS or something sits. Now whatever it is happening here will be continuously monitoring the servers. Once it is on the server, there will be environments. There will be development environment, there is test environment, then there is pre-prod environment, then there is prod environment. There are several environments that is there. And on all the infrastructure, on all the environments, a similar kind of infrastructure should be made. Similar infra must be made. For example, let us think that one second, please. One second. For example, let us think that there are 5,000 servers which are running, which are running behind a particular application. So, for example, if you want to develop it, test it, pre-prod, prod, you will be having similar kind of environments. You don't need those many servers, but you need similar kind of environment. So, creating the same infrastructure again and again and again and again till production will be hindrance. Correct? So will become a hindrance. So what we will be using infrastructure as code to make this process run. Here in infrastructure as code, in this automation, you have two things. First is an infra provisioning tool. The infra provisioning tool will become infra provisioning tool. This infra provisioning tool will become Terraform. And then there is this configuration management tool. For example, there are 5,000 servers that are there. To make a particular server ready, for example, I want to host an application. For example, if I'm using LAMP stack, then in the LAMP stack, you will be having Linux, Apache, MySQL, PHP, for example. This is the famous stack on which the Facebook used to run. So, for example, there is LAMP stack. So this LAMP stack, if it is running in one server, it is okay. For LAMP stack, you need Linux. And then on Linux, you should be configuring Apache server with MySQL and then PHP. So this whole environment should be run, right? For example, there are around 10,000 servers which are running on the same stack. So all the infrastructure on the 10,000 servers should be made. How will you make the infrastructure on 10,000 servers? You won't be sitting with every other server and dealing with it. You will be using a tool called Terraform to do it. So then there is, for the provisioning of the servers, you will be using the Terraform. For the 10,000 servers to come and sit on the infrastructure, you will be using Terraform. Then for installing the applications like the LAMP stack, you will be using something called Ansible. You'll be writing some Ansible playbooks, and by using those playbooks, you will be configuring everything. If I am talking about each and every DevOps tools right away, for example, there is also monitoring. But the entire monitoring will be done by using Nagios or Prometheus or Grafana. There are a few more tools that are there. Many companies are using Prometheus these days. So this monitoring, the whole process will be monitored. And also for keeping all the scriptings of configuration management like Ansible or Chef or Terraform, you also need a repository. So you need to have a good understanding of Git again here. So these are the several tools that will be coming into picture while we are talking about DevOps. Nice, very good. Now coming back, where will we start? Where will we start? This is one question that will come into picture. There are so many tools now. Where will I start? We will start with Linux and learn the Linux administration. Once the Linux administration is complete, we will be learning AWS. Once the AWS is over, then we will be starting DevOps. In DevOps, we will be learning Git, Ansible, Terraform. Then we will be learning Jenkins. Then we'll be learning Docker, Kubernetes basics we will be doing. And then we'll be doing Prometheus, Grafana. Then we will be also dealing with some other tools like JFrog, SonarQube. Then we will be dealing with the ELK stack. Otherwise, we will be talking about the Splunk for the log management. Like this, we will be learning tools step by step. So this is about the demo. You can ask me any questions if you have. Hello? If you have any questions, you can ask.
Nagbhushan?
Yes, sir.
So any questions from your end?
Sir, these tools are very much, I think, can we complete within these 3 months of short period, sir?
Correct. Yes. We will finish it in 3 months. Yes.
Okay.
Because we will be going in an approach. For example,
Okay.
We will be following an approach. For example, we will be starting with Linux. Then we'll be going to AWS. We'll go step by step, and we'll cover everything.
Okay, sir. Thank you.
Yeah. Anything else? Anything else? Ganesh, you can take over, I guess.
Sai Venkatesh and Santosh, any questions from your end?
No, sir.
And Sai Venkatesh? Okay, then if you don't have a question, then we can wind up for now.
Okay, then. Thank you. Thank you.
I'll cut it tomorrow then, everyone.